Okay, so in this video, I want to look at solving some obviously more triangles using law of cosines. Law of sines may also pop up, but a lot of these are more application problems, or using things like bearings or things like that that are also equally challenging. Okay, so this problem, example 3 from the notes, says a ship leaves a port with initial bearing of 320 degrees. Now, in the whole idea of bearing, there's two ways to express bearing, and you saw that hopefully in that video. But if it just says like a bearing of 320 degrees, remember that's from due north. So if I were to draw, that, like, here's north, south, east, west, and I drew 320 degrees. Remember, that's from the north, and that's obviously a little bit counterintuitive to what we're used to with the unit circle. But here is a bearing of 320 degrees. So it's going in this direction. It's going northwest. So that big angle right there is 320 degrees. And then it's in open sea, and now it's moving. So it's moving exactly east. Okay, so what I might do is I might take this, if I can grab this. That's okay. I'll just redo it. I want to have a little bit more working space here. So now I kind of have my bearings on where it's going, haha, pun intended. And so, there we go. So I know it has an initial bearing of 320 degrees. There's north. Okay, east, south, and west. Okay, so let's switch colors here. Okay, so 320 degrees. So we know it's heading in this direction. And it might continue. Like, I always like to draw the trajectory, because that's going to help me answer, like, what angle did it turn through? So if that big angle here is 320 degrees, I would know that this angle right there would be 360 minus 320, which is 40. So at least I know that right there is 40 degrees, in case I need to know that. And then the ship now is traveling due east. So now it's going to be going in this direction, due east. Okay. And it's going in that direction for 10,000 meters. So I should probably start labeling that this is 10,000 meters. And then this was 1,200 meters. And, now I can really set up my triangle, because if I draw from the initial port to that instant right there, that'll complete that triangle, and that'll allow me to use law of cosines, law of sines, to solve for all the missing pieces. Okay, so one of the very first questions says, through what angle did this ship have to turn? And so you have to kind of think about this ship from like the tip of your pen or the tip of your pencil. So you have your ship, and your ship is going in that direction. So here it is. Here's my ship. Right? So it's going in this direction, and that arrow has to turn to get pointed to that direction, and now I can go out there. And so that turn that I just did, right, it's the outer turn of the triangle. That's the angle through which it turns. Oops. So the angle that question's referring to is actually this angle right here, because that would be the angle that the actual bow of the ship, the front of the ship, would have to turn through. And so that's not part of my triangle, but if I could find this part of the triangle, then I would know to take its supplement. And that part's really easy to find, because I went due east. Going due east means I've created a right angle right there. And I knew that this angle here, down here, was 40 degrees, because that would have completed, right, the bearing of 360 minus like 320 to get 40. So I know that theta right there is 50. So if I know that theta is 50, I'm doing all sorts of colors today. So if I know that theta is 50 degrees, then the outside here, the exterior there, is 130 degrees. And so that's the angle that the ship had turned through. Okay, now it also says how far is it from its starting destination. In other words, how far is this segment there? Okay, so call that X. And when I see this triangle, I'll go back to the highlighter, I think. There we go. when I see this triangle, I want to think about what are all the pieces that I know. I know this theta is 50 degrees. I know a side length of 1200 and a side length of 10,000. I'm looking for x. That's a side angle side case. So when I'm sitting in side angle side, I know I can solve using law of cosines. Okay, and so I'm going to say x squared is equal to 1200 squared plus 10,000 squared minus 2 times 1200 times 10,000 times cosine of 50 degrees. And again, make sure you're in degree mode for this problem. The default is radian, and if if you reset your calculator's batteries or recharge it, it'll go back to radian mode. So make sure you're in degree mode. And once again, I should have worked this out ahead of time, but I didn't. So now you get to hear my clicks. Times 10,000 times the cosine of 50 degrees, and then I will square root my answer, and I would get, let's see, make sure I'm in the right mode, make sure I am in fact in degrees, good. So I got x to be 9,274.325 miles. Okay. So just another application problem of law of cosines. But again, I think what makes this one a little bit more challenging is that first question. What angle did the ship have to turn? Because a lot of students will accidentally say, oh, that angle is 50 degrees. But it's not. It's the angle that your ship actually would have turned. So again, thinking about your ship as the point of that arrow. Here's the ship moving, 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 moving. I'm actually going to spin it, not you. I can actually spin you 130 degrees, and now I'm heading in that direction right there. Okay, so the next one I want to do is actually on the next page called practice problem number 1. Another similar question. It's a bearing problem. And again, it's a bearing of 130 degrees. It doesn't give us with due, north, south, east, west. So we know it's assuming it's from due north. So 130 degree bearing from due north. Let's see. So go to my pen. And oops, my bad. Pick a color. Let's go that color. So 130 degrees and a speed of 35 miles per hour. So 130 degree bearing. So there you go. It's from due north. So 130 degrees, there's 90, 40 more. So we're going in this direction right here. And if it turns, it might. But anyway, there's my trajectory. So it's 130 degrees right there. That's my 90 degrees, so I know that at least that angle right there is 40. And then it says at 35 miles per hour. After 2 hours, the ship turns 90 degrees towards the north. So 2 times 35 would mean that distance is 75. And so, 70. So let's go ahead and label that as 70. Distance there is 70, and it's going to turn towards the north and head in that direction. So again, thinking about that arrow, it's heading in 90 degrees, so it's heading in that direction. So now I have this, and so I know that's a right angle. That's a right angle. Okay, so and again, I might say, oh, it is traveled there for 3 hours. So then if I had another 35, so that's 105 miles on that side. Okay. So now it says, well, what is the bearing of the ship? And so the bearing of the ship has to be with respect to due north. So if I think about like this north, south, east, west compass, like if I were to measure, try this one more time. It's still waking up this morning. Let's try it one more time. If I were to, okay. So it just doesn't want to cooperate. I'm going to try this a second time. So I'm so sorry. See, this is all the fun that we get to have on this distance remote learning. Let's go yellow. So let's do this. So this will be my golden compass here. And can I grab that there? Okay. So I want to know, I want to know, how is this in relation to, group it. There we go. Oh, maybe I don't need to. So I want to know, this angle here, or actually this angle out here from due north, what is that angle? I'm looking for this this angle compared to due north. This angle right there. Thought I had red. Try again. Nope. Thought I had red. Try one more time. This angle right there. Okay. So I'm looking for that angle right there. That would be its bearing because I'm comparing it to due north. But if I think about where else would I see that angle, as I think about as I'm sliding that angle around, like where else do I? All of those places. Where do I see that? Is I think about sliding that guy down. Like I want to know. Oh, if I could find this angle here. Okay, this is these I gotta go. Sorry. Let's get rid of that. Let's get rid of that. If I look at this angle here, if I look at this angle here, oh, that's fun. Okay, pen. There it is. This angle here, I would be able to find this angle because those are vertical angles. And then if I just kind of think about sticking that perpendicular here, like this is the angle that would be, compared to due north. So sorry about that long explanation, but let's use our right triangle. Let's go back and fill some things in. So I know that this is 40 degrees here because I initially knew was 130, and that's a right angle. This is a right angle here. So if that's 40 and that's a right angle, then that is 50. And if I go across here for this to be 50, that means this right here is 40. So that's my new bearing because that 40 degrees is what I'm comparing to due north. So that is the bearing of the ship with respect to due north. Now, if you think about how I could have gotten that another way, if you start going 130 degrees in this direction, that was your bearing from due north, and the 90-degree turn that's down here kind of counterbalance some of that 130. So you could think about subtracting that. That would give you a net change of a 40-degree bearing. So that's another way we could check our answer. Okay, how far is the ship from Miami after 3 hours? So we've already drawn that 3 hours, and so what we're looking for is actually this distance here. Right, I'm looking for that distance there. Here's a triangle, and we know it's a right triangle. So if I know that this is 70, that's a right angle, and this is 105, I should be able to use the Pythagorean theorem. Don't even have to use law of sines or cosines to find that missing piece. So let me erase this little guy over here and all this other gobbledygook. So I could do that, and I know that there it is. I know that 70 was 35 times 2, and 105 was 35 times 3. So I'm just thinking of a method of reduction in geometry, that if this were 70, and this were 105, and this is x, if I divide those out, that might make my work a little bit easier. So divide by 35, that's 2. Divide by 35, that's 3. So 2 squared plus 3 squared, 4 plus 9 is 13. So this would have been root 13, but then because we divided by 35, we could multiply by 35. So I would say that it's 35 root 13 miles. Now, if you wanted to use your calculator to get the decimal, 35 root 13 would be about 126.194 miles. Okay. Now, last one. What is the bearing of the ship with respect to the port? So not just any arbitrary north-south, but just this particular initial north-south. So in other words, what I'm looking for is this angle. Let's go maybe yellow. This angle right here, because that's the angle with the initial due north. And it's a little deceiving because you're like, oh, it's just 130 minus 40. But it's not, because 40 is from the measure from the east. I need to figure out how much this angle is right there. Because that angle, if I could take that angle away from 130, that would give me that would give you the bearing from the port at that instant. So I'm going to call that angle theta, and I know that it's a right triangle. So I could say that, well, the tangent of theta is equal to 105 divided by 70. So if I do inverse tangent, and I say, okay, inverse tangent. Now I do know I'm introducing this inverse tangent sign. So I have to think about where else could this tangent be that would have a positive ratio, and it's 56.3099 or 310 degrees. But the thing is that angle, it also has it in, if I would draw that out down in quadrant 3 as a reference angle, that makes no sense because now it's bigger than 180, and I know that this is definitely in a triangle, let alone it's the acute angle. So I know that this theta is 56.310. I take that away from 130 to get the bearing with the respect to due north, to get this angle right there. So 130 minus 56.310. And so then we get a new bearing of 73.690 degrees. Okay. And remember, when it asks for a bearing with respect to the port, it's going back to your original north-south. If it just says what is the bearing of the ship, it's with like any north-south from that exact point where the ship is at. So, okay. Now, I want to go through a couple more examples. So I'm going to stop this video, and maybe you could try a couple before before I solve them out. But that's really just making sure you can get through the bearings, and then law of sines, law of cosines. It could also even just be, a right triangle.